They what? They have the same slope. Good.
Hey, once you got some paper out, you're taking some notes that you needed.
Now, how this intertwines themselves with triangles and with lines is something very, very, very easy. And you guys already know this answer. How many degrees are inside of a triangle? 180, right? We all know that? I hope. So, when you have a triangle, let's see if I can, I'll just use the button because it's nicer. Oops. When we have a triangle, how many angles are there? There's 3 of them, okay? So I'm going to call this, when you have angles, marker hasn't been doing very well today. This is 5. Yeah. And triangles. Remember how we talked about labeling angles before? We would label them with 3 letters. The middle letter was always the, starts with a V, yeah, vertex, good. So with triangles, we have 3 angles. Obviously, it's triangle. Now, the vertices are generally labeled just with 1 capital letter, and since there's no other angle that can be at angle A, we'll just call that angle A. There's no other angle that can be at angle B, so we just call it angle B, and same thing with angle C. The minute that we draw something, don't draw this one in, the minute we do something like this though, I can't call that angle A anymore because there's 3 different angles that it could be. Does that make sense? We discussed this a while ago, I just want to remind you guys. So, we know that angle A plus angle B plus angle C has to be 180 degrees, because that's how many degrees that you can have in a triangle. Can you have more than 180 degrees in a triangle?
No.
No. Could you though?
Depends on how many you have.
Well, each triangle that you have is still a triangle. There's just 3, right? Well, it doesn't really though. I mean, this little triangle here versus this one. Oh! There's still 3 angles, right?
Yeah. It depends on how many lines you have.
But still, the triangle of itself, even if there's other lines through it, if you're saying, isn't this still a triangle, this is still a triangle,
yeah,
and the whole thing's still a triangle? Well, how many degrees can be in this triangle? 180. How many degrees can be in this triangle? 180. How many degrees can be in the big triangle? No, still just 180. No matter what's happening here, okay? Now, you guys know that you guys remember when we talked about planes? You guys remember planes?
Yeah.
Yeah, they're good.
Plane, what we said was a flat surface extends in all directions. In college geometry, it's called axiomatic geometry. You get what are called different planes. The spherical plane. What's that? Yeah. So the spherical plane is still a plane. This is something you guys need to worry about here. But in essence, what you can do, you guys have all seen a globe, right? You know how you got the poles, equators, things like that, longitude, latitudes. You can put a dot on the North Pole. Draw it down so that it's perpendicular to the equator. So you get a right angle. Draw across the right angle, draw across the equator, go back to the pole, come straight down again, so it's a right angle up top. And then you can have another right angle then at the equator. So isn't that still a triangle? 3-sided, 3 angles? But there's 270 degrees in it. Because it's curved. So you could, in theory, have more than 180 degrees in a triangle, but it can't be on the regular plane. Just like kind of cool. Something different. Something different. All right. But anyway, back to this. The reason why we talk about triangles and parallel lines is something super, super easy to look at. For example, one of the things that happens with triangles is that, do you guys agree that, oops. Where's the Do you guys agree that this is just some point right here? This is a dot. It can be any, like, if you think about it, if we had this on a grid, it could be some sort of an ordered pair if you want. Are you okay with that? Now, if I wanted to be, and I say this is, we call this what, angle A, B, and C. This line here goes through that triangle. You okay with that? If I drew a line here
Parallel.
that's parallel to it,
You get a line going through both of them. Like one end on the top. Somewhat.
I see where you're going. I see where you're going. But when we have two lines that are parallel, if I look here, how many angles are there now? I'm sorry, here. This, how many angles are there? Three. Those three angles create a line, don't they? Are you okay with that? Now, these three angles, we'll call this 1B and 3. Angle 1. Excuse me. Excuse me. We know that these three angles create a line as well. We'll call it 1, 2, and 3. Now, what happens here is that you can actually set up something that's called an exterior angle. Those are heavy. You didn't steal that, did you? You sure? I know. It's funny that we ran. I coach her cousin. I'm sorry, your nephew. No, yeah, your cousin. Yeah. Her ran into some family members of hers over the weekend. Had to tell the story again. It's pretty. I know, it's pretty great. Is it fun? It was very fun. Very funny. It was funny. Anyway, so what happens then is that we can do stuff like this. We did this, and we know that those three angles add up to be angles 1, 2, 3 are also 180. I'm sorry, guys. But what happens here is that we can get into triangles now. And like we were talking a second ago about going into the 180 stuff, we can find missing angles. Yeah, try and draw this one out real quick. I'm going to show you guys. What's going to happen here is we're just going to be finding missing angles, guys. How do you find a missing angle here and there? The algebra that we're going to have is, 1-step, 2-step stuff. We know that angles are going to equal, that all three of them inside of a triangle have to be 180. We know that two angles that are next to each other have, if you have that, for example, if this side here is 75, this side would have to be the supplement. All right, little things like that that we've done.
Wow.
Yeah, because you can drag and move it around when you do that one. Yeah. So I use that one. I use the open reference one all the time for constructions. So when you look at this stuff here, guys, what's that? When you look at these types of problems, you'll notice that in this one problem, there are 3 questions they're asking us to find. Angles X, Y, and Z. There's usually, with this style of problem that you'll come across here, an easy one to start with. What's the easy one to start with here? Z. You're seeing Z. So Z is part of the, let's try to highlight this up a little bit. Angle Z is part of the large triangle, isn't it? Now, that means that you'd have to figure out, well, it's 59. This angle, how much is this whole angle going to be?
That whole angle is
How much? 92? Yeah. That whole angle has to be 92 because it's made up of the two smaller ones. So you're doing angle addition again. So if I add those two together, we get, let's see, 151. How many degrees are in a triangle? 180. So if I take 180, I back out the 151, you're left with what, 29?
29.
So Z is 29 degrees. Okay?
That's it?
We can make this more difficult if you like.
No. Like, that's easy, like.
Okay? Now, as you get into the triangles then, you have to get this X and Y value. But notice, isn't this part of that one triangle here? So again, you're adding up 29, and in this case, 49. Well, add those two together. I believe you get 78. That means how many degrees are left to get your Y? So you take the 180, and you back out the 78, very good. And you're left with 112. Yeah, to make sure that you did this correctly, because if you go to the other one then, we're at 43.59 and something. You're at 102, which means how much is left then for X? 78. And that should be 78 because don't these two create a line? Doesn't the X and Y angles, don't those two create a line? Yeah. And that's how this stuff's going to work. Okay. Not terrible. Again, pretty sure most of you guys have done something like this before. I don't think it's going to be very scary, shall we say. What's the other one? Ooh. A new term. This is where I was kind of going with the parallel line stuff here. You guys ever heard of a thing called an exterior angle? What is it? What's it? Yeah, it's just an angle on the outside of a shape. That's all it is. So it's not a real tough one here. Exterior angle. Really, really simple. It's an angle on the outside of an object. We use exterior angles a lot, especially later. When you have, if I can draw this. It's not terrible. All right, it's not great. It looks kind of like Bert a little bit. It does look a little bit like Bert. That's I know.
I think you should use.
How many inside angles are in that object? 6. Which means how many outside angles are there? 6. How many inside angles are in this one? Which means how many outsides are there? How many inside angles are in a triangle? Which means how many outsides are there? 3. Now, here's what happens here. Whenever you have this thing called an exterior angle, it's always drawn on the outside of an object. Yeah, I saw that. And you don't have to try and draw this. What's that?
It's like one of those.
Sprinkler.
Oh, no, like a pinwheel.
A sprinkler. Better way. Did you just spin it?
Whoa, what are you talking about?
No, that looks like one of the sprinklers that
Anyway, so what happens here is that you'll see a relationship between the outside angle and the inside angle. If this inside angle is 100 degrees, what does the outside angle have to be? 80. So interior and exterior angles are always supplementary to one another. Okay? Interior and exterior are always supplementary, no matter what the shape is. Okay?
Is there a name for that?
That create a line that are supplementary?
Yeah.
Gee, I wonder.
Oh wait, is it called lines have same shape?
No. No. Remember linear pair?
Oh yeah, that
So again, if you go back and you look at just the basic triangle. If we go back to the triangle, we have outside angles. So if this angle here is 55 degrees, what would this angle have to be?
55 degrees.
No.
No, wait.
It has to be, subtract that from 180, what do you get? 125, good. All right, so the relationship that happens with outside, the exterior angle, the exterior angle, and its interior form a linear pair. For about what? Okay. The exterior, excuse me, the exterior angle and the one that's next to, they always form a pair. Always, always, always.
And there's something, you guys know that when two angles are adjacent, there's something, right? There's something.
Yep.
So those two angles are adjacent, and then it's straight on.
And it'll always work. All right. Now, that goes to play along with the same idea. If I make that one 50,
180.
and then the other one would be 75. Because how many degrees are inside of a triangle, guys? Does that change? In our world, it doesn't change. It'd always be 180 degrees. Now, so I just made up some numbers real quick that work. I say this one was 55, that was 50, and that was 75. All three of those angles add up to equal 180. You guys are okay with that?
Yeah.
All right. So what would the exterior angle have to be?
130.
Very good.
See, I'm smart.
It has to be 130 because the two angles, they create a line. So if this is going to be 180 degrees total there, if this is 50, how much is left for the outside? Okay. Same idea here. Since the inside part is 75, the outside part would have to be 105. Okay. Now, I want you to see something. What does 50 and 75 add up to equal? It adds up to be 125, doesn't it? Those two equal 125. What does 75 and 55 add up to equal?
Oh, 180.
Try to calculate.
He said that they equal 180, all the numbers together.
I also said 75 and 55.
Oh.
It's 130. And then what does 50 and 55 add up to equal?
100.
It's all the what angles? It's all the exterior angles, isn't it? Now, if you look at that, and I'm glad you picked up on that, she noticed that the 50 and the 75 added up to equal the exterior angle. The 55 and the 75 added up to equal the exterior angle up there.
The angle that's not touching.
The angle that's not touching, that's the big thing.
Yeah.
So what happens here is with this exterior angle, it's a nice little trick. The exterior angle always always equals the sum. What does sum mean again? Yeah, of the two angles it does not touch.
Sometimes they're called remotes, interior angles. If you think about the remote parking lot, if you've ever gone to the airport, it's so locked, it's like far away from the airport. So if you think about that, with your interior angles and that exterior angles, it's not touching.
That outside angle always equals the sum of the two angles it doesn't touch. The reason why we say the sum of the two it doesn't touch, because what angle does it touch? It touches this one. What's that? Yeah, we label it out that way. Very good. So if it touches this angle, it's going to add up to equal to two it doesn't touch. Those two, you add them together. Okay? It works all the way around the triangle, as you just saw. All right? I can get into the whole algebraic proof of it if you want to see it, but meh.
But if you go back to your picture of the triangle, and you go back to your outside angles, and I come down here and I get a highlighter, because, and that's an outside angle, right?
Mm-hmm.
This was an outside angle, and this was an outside angle. Don't try this in your head. You add those three numbers together, and you know what you get.
Wait, all the outside numbers?
Yeah, all those, the ones that I,
360.
Because how many degrees does it take to get around an object?
306. Oh, a full circle.
if I was standing like this,
Oh, 360 degrees. It's still.
it's still 360.
Yeah.
What if you had to walk around?
But just do 180. Just do 180.
No, you still, to go around is still 360 degrees. It's not usually.
I'd be out there forever. Running down the street for the neighborhood, the dogs.
Come on, a dog.
Yeah, right, exactly. So yeah, the idea here is, guys, that your exterior angles, and this will come up when we get to polynomials later on. If I want to get all the way around this object, it's always 360 degrees. To get around any object is always 360. But for our purposes, the outside angle is always going to equal the sum of the two it doesn't. Okay? It's really, really, really fast stuff. So, if I'm looking at this one, angle 1 in this case, is that an outside or an inside angle? It's outside. So, if I'm an outside angle, I'm going to equal the sum of the two I don't touch. What is the sum of the two angles it doesn't touch? 98. So this angle here has to equal 98 degrees. Okay? Again, another way of thinking about it. How many total degrees are inside of a triangle? 180. If I know that these two angles add up to equal 98, if I subtract that from 180, I'm left with 82 degrees here. And then those two angles are always supplementary. It's just a quicker way of doing this. Okay? It's just a quicker way of doing this.
And then do you still find the outside part?
I'm sorry, what was that?
Do you still find the outside part?
No, just asking us for that one. That one angle is equal to the sum of the two it doesn't touch.
Easy.
You hope so. You don't have to. It's just the textbook that we use draws the arrows a lot of times. It just shows that it continues. It's not a big deal. We're not trying to find lengths of anything here. It's just showing that it's part. It's aligned through the points. Same idea. In this one, we have the outside angle.
So that means you have to, wouldn't you have to add? No, wait. No, yeah, you subtract it too.
We know the outside angle the outside angle, the exterior angle, the 124, has to equal the sum plus the two angles that it doesn't touch. Remember, the word sum stands for adding. Okay. So 59 and what gives you 124? All you got to do is, like you just said, subtract it out. Again, this is pretty straightforward. Okay, it doesn't get, we don't get too crazy on this stuff. Your outside angle is always equal to the sum of the two it does not touch. Okay? Always, 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 always. What's that? No, I didn't. I have more pictures so that way you guys have to keep drawing them. I made some.
Oh, yeah.
Let's skip over to some of these real quick. It's what's the weasel in Ice Age? Wow. You know what I'm talking about? That's what it looks like. Yeah. Is it Strat? Yeah. Who's the weasel? Yeah. Okay, because that's kind of what it looked like. So, again, in this one here, I want to skip over. Guys, I am looking at number 19. I'm looking at number 19. Oh, I drew a bunch of these. I put a bunch of these on here for just notes so we can have pictures. I'm looking at 19. Now, number 19 is asking us to figure out basically angle D. So, with the information that we're looking at, is angle D an inside or an outside angle?
Angle D is inside.
It's an inside angle. Now, given the other information that we have, the 65 is the outside angle. So the 65 has to equal 45 plus something. What do you do to figure out the something?
Subtract it.
Subtract. Good. And what do you get? 20. Okay. The outside angle is the sum of the two it doesn't touch. This always works. Now, will this change when you have algebra? No, it doesn't change at all. Look down at number 23.
Whoa! So excellent.
This is 23.
That's the right degree. That's the right angle.
Does it say it is?
No, you're right though.
Okay. Guys. So again, in this case here, we know that the outside angle is equal to the sum of the two it doesn't touch. So 7x plus 11 is 50 plus the 3x plus 5. Is everybody okay that I wrote 55 right away?
Oh yeah.
So I have to add these two together.
Wait, you have to add what together?
The sum of the two it doesn't touch.
Oh, you have to add the two and together?
Because the outside angle is the sum of the two it doesn't touch. From there, you've got variables on both sides of the equation. Guys, same math that we've been working on. Pick on the little guy. Subtract your 3x.
I'm sorry.
Subtract the 11 going back, and then divide everything out by 4, and like you just said, you got 11 for x. Good. Now, did this problem say solve for x, or did this problem say solve for an angle?
Solve for x.
Okay, if it said solve for an angle, what would you have to do with the 11 then?
You put it in.
You just have to substitute something back in. Okay. Take a second and do 24.
24.
It's okay.
Then I erase it.
Yeah. All right, take a second, try to 24. We redraw this here. Excuse me. So again, you have an outside angle is equal to the sum of the two it doesn't touch. So you know, just from the diagram here, that your 120 has to equal Now, be careful when you combine your like terms, guys. -3 plus -9 just gets you more negative.
Oh, wait a minute, that's what I'm supposed to do.
Yeah.
Hey, wait a minute, don't go ahead and get it.
All right. Remember, guys, if you, it happens all the time. It happens all the time. So be careful when you don't get caught by that one. All right. Add the 12 coming back, you get 132. Divide that out, and you get dun dun dun. Okay. I think it's kind of dumb luck. Let's see. Oh, I know. We didn't do one like this yet. Flip over and look at number 15. What do you have to do first?
What is this?
Guys, what do you have to do first here? Well, this is 15.
First, you have to.
What's the only thing you can do?
Why do you get rid of 65 again?
60. Yeah. So the only thing you can do right now is you know that you can do 60 and 35. What do you get? 95. Now, if those two equal 95, that means you can figure out this angle here, doesn't it?
That equals the one from the circle.
Okay, I see what you're doing.
Sometimes you'll have to use multiple steps to bounce between triangles. Remember, when you're bouncing between triangles, you use, like you just said, the vertical. All right? Everybody notice how you have vertical angles here? Remember the bow tie? When you see that bow tie a lot of times in diagrams, you're going to wind up using vertical angles to switch between the two. Don't see the bow tie picture sideways? So I know that if I subtract that out, I get 85 for this here, which means this has to be 85. How many degrees are in a triangle? 180. So you would subtract out those two to figure out the left over, which you have to bounce yourself back and forth from time to time. Let's see, I believe you get, what is that, 106, so is it 74? Were you left with 74 on that one?
Yes, sir, yes, sir, yes, sir.
So you get 74.
Okay.
Okay. Now, 16? Well, if you look at 16, they're giving you information. that box mean, guys? 90 degrees. Now, how many angles make up that 90-degree angle? 2 of them. Now, could you figure out what one part of it is? Does it say it's 45? Does it say it was bisected? No. But if you look at it, you have a triangle here. How many degrees are in that triangle? Should be how many degrees in every triangle? 180. So we already know 2 of the angles, 94 and 36. If I add those together, you get 140. No, 130, I'm sorry. So you get 130. Everybody okay with that for those 2 add up? Which means how many degrees are left for just this angle here? 50. Which means how many degrees are on this side? 40. Everybody see that? You're using what you're given here, that symbol means it's 90 degrees. Okay? So as you know that something's 90 degrees, the 2 angles have to be complementary. Remember, complementary meant the 2 angles at 90. What's 50 plus what is 90? There you go. All right. Now you have a second triangle. We have the triangle 40, 80, and something. And you get 60. All you're doing is you're using the sum of the angles in a triangle to work your way around it. What does that box mean in the corner? Yeah. Okay, how many degrees are in a right angle? How many? So 50 plus what is 90? Yep. You work your way through where we got time. Last little example, just to make sure we understand this. Shh, guys. 17. Exactly. Now, as you go through this, you only have enough information to work yourself through that triangle on the left. How many degrees are in the triangle again? 180. So we start with adding up the 58 and 79. And just back them both out of 180 out of that. So you get 27? No, I'm sorry, 47. Yeah, 47, correct? 180 minus 79 minus 58, I think is.
Why did you like that?
79 plus 50.
You get the same answer, don't you?
Yeah, but like,
I'm just doing it in my head.
you know what?
It works the same way.
Well, you did it on purpose. You did it on purpose.
All right, 58 and 79, okay?
I don't know, go ahead, do the other way. No, it's better. Thank you.
You still get 43, right?
Oh my.
Okay.
Yes, I got 43 though, yes.
Okay. Guys. So now you have your 43-degree angle inside the triangle here.
Okay.
What do these 3 angles have to add up to equal? So we have to add those together again. $116.
Minus 180.
Well, flip it around, 180 minus 116. And you get 64.
So then we got 64 on both sides. And then don't you do 74 plus 64?
Then do what with that answer? Subtract that again from 180.
And then 42 is your missing side.
Side or an angle?
Or your missing angle. That's easy, but
A lot. Doesn't take long though.
It's not like doing the other ones.
I think you have an accolade.
Do the evens on this thing for me tonight. Okay.
I'm upset.
We've done a couple examples of the evens already. Shouldn't be very tough. Remember, sometimes they're asking you to find an angle, sometimes you're finding just finding x. Just read the question carefully.